A quote from Neil deGrasse Tyson resonates profoundly: "The universe is not only bigger than we can imagine, under most scales, it is bigger than we can imagine." This statement captures the boundless nature of the cosmos and the inherent limitations of human perception. It begs questions that have intrigued humanity for centuries. Does the universe have a definitive end or a concrete beginning? And has the James Webb Space Telescope (JWST) finally uncovered the edge of the observable universe? Since time immemorial, we have sought to understand the magnitude of the world and the cosmos that encompasses it. Driven by a desire to know the boundaries of our existence, we have continuously expanded our knowledge. In ancient times, the edge of the world was thought to lie somewhere beyond the horizon, veiled in mystery. Today, modern telescopes allow us to peer deep into the universe, seeking clues to answer one of the most fundamental questions of all: is the universe finite, or does it stretch on infinitely? The James Webb Space Telescope represents a monumental step forward in this quest, offering the potential for groundbreaking discoveries. The question of whether the universe has an edge is not as straightforward as it might seem. An edge certainly exists, but its nature remains enigmatic. Is it truly the end of the universe, a boundary marking the limits of creation itself? Or could it be a threshold leading to something entirely different, another universe or previously unimagined dimensions? Just as our Earth has an edge, as do our solar system and galaxies, so too does the cosmos. Yet the boundaries we observe do not signify the end, but rather transitions into greater expanses. Tyson's assertion highlights an essential truth: the problem of comprehending the universe lies not in the universe itself, but in the limitations of human thought. The universe is larger than anything we can conceptualize, and our tools, while advanced, remain modest in the face of such vastness. With current telescopic technology, we can observe the universe up to 46.5 billion light-years in every direction, creating a visible sphere with a staggering diameter of 93 billion light-years. Even within this observable realm, we have not found an endpoint. The sheer number of stars, galaxies, and cosmic phenomena we have detected is mind-boggling, defying comprehension. It is estimated that thoroughly exploring and analyzing the known universe would take thousands of years. Yet, driven by an unquenchable curiosity, humanity continues to push the boundaries of knowledge. We yearn to uncover whether the universe has an edge, and if so, to understand what lies beyond it. The James Webb Space Telescope holds the promise of shedding light on these profound mysteries. The notion of a beginning to the universe is equally thought-provoking. Neil deGrasse Tyson's observations challenge our understanding, pointing out that the JWST has discovered fully formed galaxies in regions of space that were expected to be dark and underdeveloped. This discovery disrupts our preconceived notions. As humans, we naturally view existence through the lens of beginnings and endings, often confining our understanding to measurable, spatially limited concepts. However, studying the universe compels us to stretch the boundaries of perception and thought. To grasp the cosmos's immense dimensions, most of us must expand our mental horizons. The sheer scale of what we observe, the innumerable stars, countless planets, and extraordinary cosmic phenomena challenges narrow, constrained minds to open. Astronomers and cosmologists, in particular, are tasked with embracing a free-spirited, open-minded approach to their work. Yet even the most forward-thinking scientists must grapple with the realization that their understanding remains limited and often shaped by boundaries that obscure deeper truths about the universe. The JWST has proven instrumental in pushing these boundaries. It has revealed 6 ancient galaxies that appear so old and perfectly formed that their existence challenges current scientific theories. Designed to peer into the so-called dark ages of the universe, a time when the first stars and galaxies were believed to have formed, the JWST instead presented rows of ancient, well-developed galaxies. These findings prompt fundamental questions: are we truly witnessing the universe's temporal edge, where time and space began? Or did the dark ages, as we imagined them, never actually exist? Have we perhaps created constructs to fill gaps in our understanding? In addition to these 6 galaxies, the JWST also detected an enormous galaxy cluster that formed astonishingly early in cosmic history. Galaxy clusters, comprising millions of galaxies grouped together, were previously thought to form much later in the universe's evolution. The discovery of such a cluster during what was believed to be the universe's infancy challenges our understanding of cosmic development. It calls into question the sequence of events that led to the formation of stars, star clusters, galaxies, and galaxy clusters. Furthermore, the JWST has identified numerous galaxies with a redshift greater than 10, indicating they existed when the universe was only 2% of its current age, a mere few 100,000 years after the Big Bang. These galaxies do not align with the notion of a dark universe in its early stages. Instead, they reveal a cosmos remarkably similar to the one we observe today. The implications of these findings are so extraordinary that scientists initially questioned their validity. However, the JWST's advanced spectroscopy technology, which analyzes light to determine the properties and distances of celestial objects, has repeatedly confirmed these results. Spectroscopy has played a crucial role in verifying the distances and properties of these ancient galaxies, offering robust evidence of their existence. These discoveries highlight the limits of human understanding and the vastness of the unknown. As Tyson aptly stated, the problem is not the universe, the problem is us. Because we think we know more than we actually do, the universe, in all its enormity and complexity, continues to humble us, pushing the boundaries of knowledge and forcing us to rethink our place within it. The JWST is not only reshaping our understanding of the cosmos, but also challenging us to confront the limitations of our perceptions, urging humanity to remain open to the endless possibilities that lie beyond what we currently know. The method to break down the light of an astronomical object into its different wavelengths allows scientists to determine the age of the light source and physical properties, such as its chemical composition. Observations from the James Webb Space Telescope JWST have shown that certain galaxies are not only extremely old but also contain elements and a number of stars that challenge the concept of a young universe. While the temporal edge of the universe appears to be moving further away, the question of a spatial edge remains unresolved. Searching for the universe's edge presents a paradox. To locate it in real time would require us to physically explore the cosmos, an impossible feat with current technology. This is akin to searching for walls in a dark concert hall illuminated only by a few distant LED lights. Unlike the concert hall, where you could eventually feel your way to the walls, in the cosmos, we rely on telescopes to peer deeper into space. However, even the most advanced telescope, like the JWST, faces the challenge of observing a universe that is constantly expanding, akin to trying to track moving walls as they shift. Complicating matters further, light takes time to travel through space, meaning the JWST captures images of the universe as it existed in the past. For example, light from Alpha Centauri takes 4 years to reach us, and light from distant galaxies may take billions of years. While this temporal delay allows us to glimpse the universe's history, it also highlights that we have yet to find any signs of a spatial boundary. Instead, we've uncovered evidence suggesting the universe doesn't expand uniformly, hinting that it may have a structure yet to be understood. This raises the possibility that looking for boundaries or a beginning might be a flawed approach. The new era of space exploration, led by the JWST, challenges us to think beyond limited dimensions and embrace the idea of infinity. The JWST continues to reveal groundbreaking discoveries, such as an active galactic center in a galaxy that existed only 570 million years after the Big Bang. At its core, a quasar powered by a black hole 10 times the mass of the Sun emits an extraordinary amount of light, shining trillions of times brighter than the brightest stars. Such findings defy expectations and remind us that the universe often breaks conventional boundaries. Even in the search for exoplanets, the JWST demonstrates the need to think beyond limits. For instance, HIP 65426 billion, a massive gas giant about 12 times larger than Jupiter, was first identified by Hubble in 2017. Thanks to Webb's advanced spectrometers and coronagraphs, this planet was imaged directly, a rare achievement since most exoplanets are discovered through indirect methods like transit observations. These discoveries underscore the boundless diversity and complexity of the universe, reminding us that searching for definitive ends, edges, or limits may be a futile endeavor. Instead, we must embrace the ever-evolving dimensions and phenomena that the cosmos reveals as each new observation expands our understanding.